Good morning, students. Today we will learn design flaws and safety issues in RBMK nuclear reactor.
Yes, sir, this topic is important to understand design of RBMK nuclear reactor.
So firstly, as an early generation 2 reactor based on 1950s Soviet technology, the RBMK design was optimized for speed of production over redundancy. It was designed and constructed with several design characteristics that proved dangerously unstable when operated outside their design specifications. The decision to use a superheated, vacuum-isolated graphite core with natural uranium fuel allowed for massive power generation at only a quarter of the expense of heavy water reactors, which were more maintenance-intensive and required large volumes of expensive heavy water for startup. However, it also had unexpected negative consequences that would not reveal themselves fully until the 1986 Chernobyl disaster.
Sir, what about the improvements since the Chernobyl nuclear disaster?
In his posthumously published memoirs, Valery Legasov, the first deputy director of the Kurchatov Institute of Atomic Energy, revealed that the institute's scientists had long known that the RBMK had significant design flaws. Legasov's suicide, apparently a result of becoming bitterly disappointed with the failure of the authorities to confront the flaws, caused shockwaves throughout the Soviet nuclear industry, and the problems with the RBMK design were rapidly accepted. Following Legasov's death, all remaining RBMKs were retrofitted with a number of updates for safety. The largest of these updates fixed the RBMK control rod design. The control rods have 4.5 meters, 14 feet, 9 in, graphite displacers, which prevent coolant water from entering the space vacated as the rods are withdrawn. In the original design, those displacers, being shorter than the height of the core, left 1.25 meters, 4.1 feet, columns of water at the bottom and 1.25 meters, 4.1 feet, at the top when the rods were fully extracted. During insertion, the graphite would first displace that lower water, locally increasing reactivity. Also, when the rods were in their uppermost position, the absorber ends were outside the core, requiring a relatively large displacement before achieving a significant reduction in reactivity. These design flaws were likely the final trigger of the first explosion of the Chernobyl accident, causing the lower part of the core to become supercritical when the operators tried to shut down the highly destabilized reactor by reinserting the rods. The updates are, an increase in fuel enrichment from 2% to 2.4% to compensate for control rod modifications and the introduction of additional absorbers. Manual control rod count increased from 30 to 45.80. Additional absorbers inhibit operation at low power, where the RBMK design is most dangerous. Scram, rapid shutdown, sequence reduced from 18 to 12 seconds. Precautions against unauthorized access to emergency safety systems. In addition, RELAP-5-3D models of RBMK 1500 reactors were developed for use in integrated thermohydraulics neutronics calculations for the analysis of specific transients in which the neutronic response of the core is important.
Sir, who was Valery Legasov?
Valery Legasov was a Soviet inorganic chemist and a member of the Academy of Sciences of the USSR. He is now mainly remembered for his work as the chief of the commission investigating the Chernobyl disaster.
Sir, now he is my favorite scientist.
So students, it's enough for today. We'll continue to further information tomorrow.
Thanks, sir. Thanks, sir, for today's information about Valery Legasov and design flaws of RBMK nuclear reactor. So if you like our video, so hit the like button. Subscribe our channel to stay tuned and to see part 3 of RBMK nuclear reactor.